Welcome to today's session on proof writing. So when writing a writing proof, what we're actually trying to do is create some statements, some logical statements which cannot be argued, which will eventually prove a statement is true or it is false. And we can do that through written statements, do that through illustration, or we could maybe even also do that through labeling. So for my example, I've got to prove triangle AB is an equilateral triangle. So in triangle ABC, I'm going to bit of notation here by using triangle symbols instead of triangle to write some shorthand. And my first statement is AB equals 4 centimeters. AB equals 4 centimeters, and this is which is given, in which case I'm just stating what is already there. BC equals 4 centimeters, and that is given, so BC equals 4 centimeters and AC equals 4 centimeters. So that's my three statements, just actually stating what is already there. My next statement is confirming that AB equals BC equals AC. So each one of these sides are equal. So QED, triangle ABC, is an equilateral triangle. So what I'm actually doing here by QED, triangle ABC is an equilateral triangle, I am actually writing my statement out, which I've been asked to prove by using the term QED. Now QED actually stands for Quod Erat Demonstratum. Can't say it to save my life, but it just literally means as demonstrated, as shown, as proven. My next example is actually when information is not completely given to us, in which case I am trying to prove that angle X is 120 degrees. So I'm starting my my statement off by saying exactly what I'm dealing with, just like the prior example. In triangle Y, so this is my triangle Y. Triangle Y is an equilateral triangle, which is given, as noted by the dashes telling us that each one of these sides is equal. That must mean that each angle, again I'm using a bit of notation, of triangle Y equals 60 degrees, which is of course given. Or you could state angles in the triangle equal 180, so 180 degrees divided by 3 would give me 60 degrees. Next, I've stated that my angle Z here, I've added this Z in here just to say that I'm going to talk about this angle, must be 120 degrees, because right here we've got a straight line, and all angles on a straight line equal 180 degrees. So if we take 60 away from the 180, we'll be left with this angle Z, which is 120 degrees. So my next statement is that angle X equals 120 degrees because of corresponding angles, or some of you may know them as F. In which case, QED, angle X is 120 degrees, which was what we was asked to prove in the first place. And this is now all done. Now for a written one, where we could be asked to use maybe some definitions for certain numbers, and use these to actually prove a statement. So my example for this is prove the sum of two consecutive numbers is always an odd number. So two consecutive numbers on one number and a number next to it. So what I'm going to say is that the first number is n, an integer, a whole number, n. So the next number, the next consecutive number, must be n plus 1, because whatever number we've got, if we add 1 to it, that is going to be the next number, so our next consecutive number. So if I put this into into a sum because it's saying the sum of two consecutive numbers is always an odd. If I add these two together, so n plus n plus 1, that simplifies as 2n plus 1. Now 2n plus 1 is the definition of an odd number, in which case, QED, the sum of two consecutive numbers is always an odd number. So different types of proofs that we could actually end up with, that we could use when we're proof writing. We could use direct proof, which is what we're using in our first two examples. So proving using the facts that we're given and using theorems. So we can use proof writing when we are working with maybe congruent triangles, similar shapes, maybe circle theorem. We can use proof writing. Proof by induction. So this is where we are going to use the idea that we can represent a group using a bit of algebra to represent the entire group. So in our third example, we actually use proof by induction because 2n would represent all even numbers. 2n plus 1 would represent all odd numbers. Proof by contraposition. So we are proving if one is true, the other must be true. So what we're actually doing is we are implying that if for one to be true, if we was to prove that something else within maybe its sequence or within its group is true, then the other must be true. And we've got proof by contradiction. Now proof by contradiction is literally as it sounds. We, rather than proving that it's true, we are going to prove that something is false. In which case, if we can prove that all else is false, then the statement must be true. Thank you very much for watching.